Welcome to the Deep Dive, where we unpack complex topics, extract the most important nuggets of knowledge, and give you a shortcut to being truly well-informed.
That's the goal.
Today, we're plunging into a topic that's fundamentally reshaping how enterprises manage their most valuable asset, data. We're talking about the data lakehouse, a paradigm shift that's unifying data, analytics, and AI like never before.
It really is a big shift.
Our deep dive today is heavily inspired by the Data Lakehouse for Dummies, Databricks Special Edition by Ari Kaplan and Amit Kara, and, other essential insights from the field.
Right. And our mission today is basically to demystify the data lakehouse, understand its critical role in modern data management, and particularly to explore how platforms like Databricks are enabling its full potential. We'll examine its revolutionary approach to governance, its unification capabilities, and how it really brings data intelligence to the forefront. Because, look, this isn't just about technology. It's about driving significant business outcomes through a smarter data architecture.
Absolutely. So if you've ever wrestled with fragmented data across countless systems, maybe struggled to integrate diverse data types for meaningful insights, or wondered how to genuinely leverage the power of AI with your sprawling enterprise data?
Which is pretty much everyone these days.
Exactly. Then this deep dive is definitely for you. Let's explore how a single unified architecture can potentially solve these persistent challenges and unlock new possibilities. Okay, let's unpack this.
Let's do it.
So to really get why the data lakehouse is such a big deal, we probably need to take a quick look back, right, at how enterprise data management has evolved over the past few decades.
Yeah, context is key here.
For a very long time, companies operated primarily with traditional data warehouses. Can you kind of set the scene for us? What did that look like, and what was its core strength back then?
Certainly. Yeah, back in the day, the data warehouse was, well, it was the undisputed king for business intelligence. It's all built upon relational databases.
Right, SQL databases.
Yeah, exactly. They excelled at managing highly structured data, sales transactions, customer records, inventory levels, everything neatly organized into tables with predefined schemas.
Very neat and tidy.
Very neat and tidy. Businesses use SQL, the structured query language, to pull out insights for reports and analysis. Its real strength lay in its reliability and consistency for those structured tabular data sets. And for a while, it was perfectly adequate. It delivered clear, consistent views of operational data.
Okay, so it was a sturdy foundation for its time, but like any technology, it eventually hit its limits, didn't it? What forces started to chip away at its dominance?
Well, the world of data it rapidly outgrew the warehouse's confines. We entered this era of what you might call volume sprawl.
Volume sprawl, I like that.
Yeah, data wasn't just growing, it was exploding. Companies went from managing billions of records to hundreds of billions, then trillions. And traditional data warehouses, often running on expensive, vertically scaled hardware, they just couldn't keep up with that sheer scale without costs spiraling completely out of control.
Right, the cost factor.
Huge cost factor. And trying to get near real-time insights, that became an engineering nightmare. It often required massive investments in infrastructure that, frankly, still couldn't deliver the necessary agility. It became pretty clear the infrastructure itself was a major bottleneck.
And it wasn't just the sheer quantity of data, was it? There was also this fundamental shift in the types of data organizations were generating and, crucially, needing to analyze.
Precisely. That was a critical turning point.
Yeah.
The rise of completely new data sources like social media feeds, sensor data from the Internet of Things, images, videos, audio files, high-velocity streaming data. It just dramatically changed the game.
All that messy stuff.
All that messy, unstructured or semi-structured stuff. And trying to force that into the rigid, predefined schemas of a traditional data warehouse. It was like trying to fit a vast, unpredictable ocean into a series of small, precisely shaped buckets.
Doesn't quite work.
It was inefficient, often impossible, and certainly not cost-effective. Look, the warehouse was excellent for what it was built for, but it simply wasn't designed for this new, diverse data landscape.
So if a single data warehouse couldn't handle this data tsunami, what was the industry's response? How did companies try to cope initially?
Well, the initial response, largely out of necessity, was fragmentation. Different lines of business, sometimes even individual departments, started building their own specialized databases and systems just to handle their specific data needs.
The birth of the silos.
Exactly. This led to what we now commonly call data silos. Imagine your marketing team having customer data in one system, sales in another, completely separate one, and customer support in yet another.
Yeah, trying to stitch that together.
Right. Getting a unified 360-degree view of your customer or your operations became an incredibly complex, manual, and often error-prone process. And even when cloud data warehousing emerged in the early 2010s, offerings from Amazon, Google, Microsoft offering benefits like lower OpEx and better scalability.
Which seemed promising.
It was promising, but it primarily addressed the scaling of structured data in the cloud, the fundamental challenge of integrating massive volumes of diverse, unstructured data. That still remained a significant hurdle. And so did the problem of data silos, because different teams might just adopt different cloud warehouses, creating new silos in the cloud.
So the quest for a better solution continued. This brings us then to the advent of the data lake. This was kind of heralded as the answer to that unstructured data dilemma, wasn't it? How did data lakes aim to solve these problems?
Data lakes were indeed a crucial evolutionary step forward. Their core purpose was really to provide a cost-effective way to store and analyze all data types, structured, unstructured, semi-structured, in their raw, native formats.
Dump it all in.
Basically, yeah. The idea was collect everything first, then figure out how to process and refine it later as needed, rather than forcing it into a predefined schema up front. This approach directly addressed the cost and, importantly, the vendor lock-in concerns associated with traditional data warehouses.
And Apache Spark played a big role here.
Absolutely. A key enabler here was the emergence of Apache Spark. Spark, as this powerful open-source distributed data processing technology, offered incredible speed and scalability for processing vast data sets. It did this by leveraging parallel computing clusters, far surpassing the capabilities of earlier frameworks like, say, Hadoop. It really made handling those diverse, massive data sets feasible.
Okay, that sounds incredibly promising, a big leap forward. But if data lakes were such a leap, why are we now talking about data lakehouses? What were the fundamental technical shortcomings that meant a traditional data lake wasn't, the complete answer?
Yeah, this is where we get into the important nuances. While data lakes were great for cheap storage and raw processing, they lacked some absolutely critical features for enterprise-grade analytics and, crucially, reliability.
Okay.
The most significant, and frankly often a deal breaker, was the absence of ACID transactions.
ACID, right. Atomicity, consistency.
Isolation and durability, exactly. Without those guarantees, you face this constant risk of file corruption and data inconsistencies. Imagine an ETL job failing halfway through, leaving your data in some unknown, unreliable state.
Yeah, that's bad.
Or multiple users trying to update the same record simultaneously, just leading to a complete mess. This meant that while you could store the data, actually trusting its integrity for critical business decisions became a huge challenge.
So data integrity was a major, major concern. What other issues kind of turned these promising data lakes into what some people jokingly started calling data swarms?
Well, another big one was the lack of schema and data quality enforcement, because
Right.
data lakes could basically ingest anything, they often did, becoming these vast dumping grounds.
Right. Schema on read, they called it.
Schema on read, which sounds flexible, but without predefined schemas or robust quality rules enforced on ingest, it became incredibly difficult to even understand the data, let alone trust it. This led to serious integrity issues and made it really hard for data consumers, analysts, scientists to trust what they were seeing.
Okay, so trust and quality. What else?
Then there was the sheer inefficiency of operations. Even small updates often required rewriting large portions of data, which is computationally very expensive and slow, especially on massive files. And because of that lack of consistency and isolation, the CNII and ACD supporting concurrent writes and appends was a significant challenge, leading to conflicts and complex, often brittle workarounds.
And when things inevitably went wrong, like those job failures you mentioned, what was the real impact?
The impact could be substantial. Job failures mid-process often resulted in corrupted data or subtle data quality issues that were notoriously difficult to detect, debug, and then rectify. Often, you'd have no choice but to restart these lengthy processes entirely from scratch.
Wasting time and money.
Exactly, wasting valuable compute resources and delaying critical insights. Furthermore, while data lakes could store unstructured data, managing immense volumes efficiently was still a struggle. Performance would often degrade as the number of files increased, the infamous small file problem.
Ah, yes.
And trying to understand relationships between diverse data sets without any guiding schema became a Herculean task for anyone trying to use the data.
Yeah.
And finally, you'd end up with this file proliferation issue, either millions of tiny files, which kills read performance, or a few gigantic ones, which makes updates a nightmare. Both negatively impacted performance and manageability.
Wow. Okay. It really sounds like the industry was caught between a rock and a hard place. You had the traditional data warehouses for structured data, reliable but inflexible and costly at scale, and then the data lakes for unstructured data, flexible and cheap, but lacking reliability and governance.
That's a very good summary of the dilemma.
So, what were the tangible consequences of companies trying to sort of patch together these disparate solutions? Trying to make a data lake, talk to a data warehouse, talk to an ML tool.
Oh, the consequences were immense complexity, often prohibitive costs, and a significant drag on innovation. Data professionals were spending an inordinate amount of time, sometimes most of their time, simply moving and copying data between these different systems.
The ETL nightmare.
The perpetual ETL nightmare. From lakes to warehouses for BI, then maybe out to specialized tools for machine learning or reporting. This often meant storing 2, sometimes even 3, redundant copies of the same data.
Tripling the cost right there.
Effectively tripling storage and maintenance costs easily. But beyond the financial drain, there was a profound lack of unified access control. Security and permissions became this fragmented nightmare across systems. There was no single source of truth for auditing data usage, which made regulatory compliance incredibly challenging and risky.
Yeah, compliance is huge.
And, of course, just the operational overhead of managing multiple vendor contracts, integrating dozens of different tools. It just added layers and layers of complexity that stifled agility and made it nearly impossible to get a cohesive, real-time view of the business. It was holding companies back.
Okay, here's where it gets really interesting. After all that evolution, all those attempts, and all those persistent challenges, we finally arrive at the advent of the data lakehouse. This sounds like the concept designed to finally bridge that gap. What makes it so revolutionary compared to what came before?
This was truly a watershed moment in data architecture. I mean, for the first time, the data lakehouse architecture enabled companies to analyze massive amounts of both structured and unstructured data together in a single unified platform.
Together, that's the key word.
That's the fundamental breakthrough. It directly addressed and overcame those previous barriers of cost, scale, speed, and complexity that we just talked about. The Lakehouse fundamentally broke down those long-standing architectural silos. How? By taking the best attributes of both worlds. It takes the raw data flexibility and the cost-effectiveness you get from data lakes, and it combines them with the reliability, the analytical power, and the strong governance features you expect from traditional data warehouses. It's not a compromise. It's really a synergistic unification.
A unification. Okay, so what are the fundamental aspects, the core pillars that define this unified vision?
There are a few absolutely core pillars. First, and this is paramount, it introduces unified data governance. This means centralizing control and visibility over all your data assets, structured tables, unstructured files, models, everything irrespective of type or location. This finally eliminates those pervasive data silos we discussed.
One governance model to rule them all?
Sort of, yeah. Second, it offers a truly unified architecture, one that seamlessly combines traditional data warehousing workloads, like BI reporting, with modern AI and machine learning use cases, all in the same place, on the same data.
Huge simplification.
It dramatically simplifies the entire modern data stack for everyone involved: data engineers, analytics pros, BI users, data scientists, ML engineers. Imagine everyone in your organization operating on the same trusted data in the same environment with consistent access controls. That's what the Lakehouse delivers.
That sounds like the dream. And what are the foundational open source technologies underpinning this revolutionary architecture? Because that openness seems key.
It is absolutely key. The Lakehouse is built on incredibly powerful and widely adopted open source software. Key examples include, of course, Apache Spark, which serves as that powerful distributed processing engine for all types of data transformations and analytics.
The workhorse.
Definitely the workhorse. Then there's Delta Lake. Delta Lake provides that crucial storage layer, bringing AC transactions, scheme enforcement, time travel, and other data warehousing capabilities directly to the files stored in your data lake, typically in open formats like Parquet.
Okay, so Delta Lake brings the reliability.
It brings the reliability layer. And then you have things like Unity Catalog, which provides a robust open source framework specifically for unified data and AI governance across the Lakehouse. These open source foundations are critical not just for flexibility and community support, but specifically for preventing vendor lock-in. It ensures your data remains truly open and portable for the long term.
Right, avoiding getting locked into one vendor's ecosystem. So, given all that, how does a data lakehouse stack up against those legacy solutions we've outlined? What are its most compelling advantages in practice?
The advantages are genuinely transformative. They move businesses from being reactive to data to being proactive. For one, the sheer speed is remarkable. With optimized engines and capabilities like in-memory processing, data lakehouses can be orders of magnitude faster, often cited as up to 100 times faster for certain workloads compared to traditional systems.
100 times. Wow.
That's not just about faster reports, it's about shifting from that reactive analysis to proactive decision-making at the speed of business. It lets you seize fleeting market opportunities. They also offer tremendous ease of use. They support popular languages that data teams already know: Python, R, SQL, Scala, making them accessible to a much broader range of data professionals across your organization.
Democratization, almost.
In a way, yes. Versatility is another massive benefit. They seamlessly handle both large-scale batch processing for historical data and real-time streaming data from sources like IoT devices or social media feeds. This ensures your insights are always based on the freshest possible data, making them truly actionable.
And crucial for today's world AI.
Absolutely crucial. Lakehouses are designed from the ground up to enable advanced analytics, machine learning, and increasingly generative AI workloads directly on that unified data foundation. And finally, they provide robust fault tolerance. Those long-running data processes are far less likely to crash and require painful restarts, which significantly improves reliability and engineering efficiency. This combination unlocks capabilities that simply weren't practical or even possible with older siloed architectures. What's truly fascinating here is how the Lakehouse isn't just picking one side. It's intelligently taking the best elements of data lakes, like their flexibility for handling all sorts of data, their cost effectiveness, especially with cloud storage, and merging them with the best of data warehouses. Their strong analytical power, their reliability, their governance, which is critical for BI. The outcome is you genuinely reduce costs and accelerate your data and AI initiatives. It's not a compromise. It's that synergistic combination we talked about, redefining what's possible.
So if we boil it down, a data lakehouse is unified, open, and scalable. Can you elaborate a bit more on what those core attributes mean in practice for an organization? Not just the technical definition, but the strategic payoff.
Absolutely. Let's unpack those. When we say unified, it really means breaking down those stubborn data silos completely. All your data assets, structured, semi-structured, unstructured, are brought into a single, cohesive platform. Why does that matter strategically? It unlocks that holistic, 360-degree view of your customer, your operations, your market. It reveals patterns and opportunities that were previously hidden away in fragmented data islands. That unified view is a powerful strategic weapon.
Okay, unified means holistic view. What about open?
Open is foundational. Strategically, it guarantees flexibility and, critically, helps you avoid vendor lock-in. It means your data isn't trapped in some proprietary format that only one vendor's tools can read.
Future-proofing.
Exactly. It provides long-term strategic optionality. Your data remains yours, accessible. It also fosters a vibrant ecosystem of tools and integrations, leveraging community innovation.
And scalable. How does that translate strategically?
Scalable means it can effortlessly handle growth petabytes or even exabytes of data and support thousands of concurrent users without grinding to a halt. It adapts seamlessly as your business grows, without the data architecture itself becoming a bottleneck. This allows you to grow your data strategy confidently without constantly worrying about hitting architectural limits or facing massive refactoring costs. It lets you think bigger.
Makes sense. And you mentioned the underpinning open source projects, Apache Spark, Delta Lake, MLflow, and Delta Sharing. Can you quickly recap their specific roles and maybe highlight one or two that listeners might find particularly groundbreaking for their operations, maybe something they haven't focused on before?
Sure. So Apache Spark is the high-performance distributed processing engine handling massive data transformations and complex analytics at speed. Delta Lake is the storage layer that brings reliability, ACD, schema enforcement, time travel directly onto your data lake files. MLflow is your control tower for the entire machine learning lifecycle, tracking experiments, packaging models, deploying them reliably, managing versions.
Got it.
But the one I find particularly groundbreaking, especially thinking about external collaboration and even data monetization, is Delta Sharing.
Delta Sharing, okay.
This allows you to securely share live data directly from your lakehouse with any computing platform, even outside your organization, partners, customers, other divisions, without needing to replicate the data. No complex ETL, no copying files around.
Live sharing, no copies.
Exactly. Imagine securely sharing real-time market insights with partners or providing customers with access to their specific usage data, all without the overhead and security risks of data duplication. That's a potential game changer for building data ecosystems in collaborative ventures.
That seamless sharing without replication sounds incredibly efficient and secure.
Very interesting. And you also noted that lakehouses offer platform flexibility running across clouds and serve as a foundation for data intelligence. How do these elements truly empower an organization strategically?
Right. Platform flexibility is huge. Leading Lakehouse platforms, like Databricks, are designed to run seamlessly on all major cloud providers, AWS, Azure, GCP. This offers true multi-cloud capabilities. Strategically, this means you're not locked into a single cloud ecosystem. You have negotiation power, you can choose best-of-breed services, you have disaster recovery options.
Avoids cloud lock-in, too.
Precisely. They also boast broad language support: Python, SQL, R, Scala, all operating on that single unified data layer. This broad accessibility means more of your team, regardless of their preferred coding language or technical background, can work directly with the data. This fosters broader data literacy and innovation across the company.
And the foundation for data intelligence part. Yes, this is looking forward. The Lakehouse forms the essential foundation for these next-generation data intelligence platforms. This is where you start leveraging generative AI and advanced analytics, not just to process data, but to deeply understand the semantics of your data, its meaning, its context, its relationships. This moves beyond just storage and processing to true data understanding. It opens up entirely new possibilities for democratizing data access and AI capabilities across your entire organization, empowering everyone to make smarter, data-driven decisions.
That's a great segue into the key technical concepts that really differentiate a lakehouse. Let's dive a bit deeper into what truly makes it tick, maybe starting with this idea of openness. We touched on avoiding vendor lock-in, but what are the other real strategic benefits beyond just that?
Openness is really a core philosophical tenet of the Lakehouse. And you're right, its benefits extend far beyond just avoiding vendor lock-in, though that's a significant advantage, potentially saving millions in switching costs down the line. Openness provides unparalleled transparency. You're not dealing with a black box system. You're using technologies with open standards that are auditable, understandable, and often driven by large communities. It fosters a vibrant, innovative ecosystem of tools and integrations, meaning you have a much wider array of options and can leverage the collective intelligence of the open source community.
More choices.
More choices, often best-of-breed choices. Your data itself isn't tied to proprietary storage formats. It typically uses widely adopted ones like Delta Lake, built on Parquet, or Apache Iceberg, ensuring long-term data portability and accessibility. For governance, something like Unity Catalog OSS provides an open framework, and MLflow offers open ways to track experiments and deploy models. This commitment to openness fundamentally future-proofs your architecture because your data assets are truly yours, adaptable to future technological shifts, rather than being held captive by a single vendor's roadmap. It gives you control, flexibility, and a clear pathway to continued innovation.
Okay, openness is about control and future-proofing. What about the concept of decoupled storage and compute? Why is that such a critical technical design principle for achieving both massive scalability and significant cost efficiency? Seems almost counterintuitive.
It's actually fundamentally transformative for resource management and cost. In traditional monolithic data warehouses, storage and compute were often tightly integrated, bundled together.
Right, you bought an appliance.
Exactly. If you needed more processing power for a surge in queries, you often had to scale your storage capacity too, even if you didn't need more storage space. This led to wasted resources and inflated costs. With decoupling, which is native to cloud architectures and the Lakehouse, you can scale your data storage independently of your processing power, and vice versa.
Scale them separately.
Precisely. You can provision exactly the amount of compute power you need for a specific workload, maybe a massive batch transformation that runs once a day, or thousands of small interactive queries hitting simultaneously, and then crucially, spin that compute down when it's done, without affecting your underlying data storage at all.
Elasticity.
True elasticity. This enables truly cost-efficient and highly scalable systems. It allows organizations to support virtually unlimited data volumes and potentially thousands of concurrent users without the compute resources or the storage capacity ever becoming a bottleneck for the other. This translates directly into lower operational costs, better resource utilization, and the ability to handle unpredictable workloads with much greater ease. It's a smarter way to use cloud resources.
That sounds like a remarkably intelligent way to manage resources and respond dynamically to demand. Let's pivot to governance. The outline mentions unified governance for data and AI assets, specifically highlighting Unity Catalog OSS. How does having this central source of governance really revolutionize how an organization manages its data and increasingly its AI initiatives?
Unified governance, anchored by solutions like Unity Catalog OSS, is absolutely paramount for any robust modern data strategy. Especially in today's highly regulated and security-conscious environment, you just can't afford fragmented governance. It acts as a single, central, and comprehensive governance framework for all data and AI assets within your lakehouse.
All assets, not just tables.
Not just tables. That's the key. It extends beyond structured data to cover raw, unstructured data, like images and videos, machine learning models themselves, generative AI assets like prompts or agents, analytical notebooks, dashboards, the whole ecosystem. Unity Catalog provides end-to-end visibility and critically fine-grained control over all of it.
Okay, so what does that control look like in practice?
It means having complete audit trails to track who accessed what data or model and when. It means robust credential management for connecting to various external data sources securely. And it means full data lineage tracking, being able to see precisely where a piece of data came from, how it was transformed, and where it's being used, maybe in a report or to train a model.
Traceability.
Complete traceability. This level of transparency and control is crucial for maintaining security, for ensuring compliance with regulations like GDPR or HIPAA, and frankly, for fostering trust in your data assets across the organization. It also powers sophisticated data discovery, allowing users to quickly find and understand relevant, trusted data, which fosters collaboration while maintaining tight security policies. Trying to do this across dozens of siloed systems was a nightmare. Centralizing it makes it manageable and effective.
So it's about making data visible, discoverable, and perhaps most importantly, truly trustworthy across the entire organization. Building on that, how does the Lakehouse, with its unified architecture, specifically enhance support for both modern AI workloads and traditional business intelligence? They seem like different worlds sometimes.
They often operate differently, but the Lakehouse brings them together on common ground. For AI machine learning, deep learning, Gen AI, the Lakehouse provides that unparalleled unified data management we talked about. This means your models can access all your corporate data assets seamlessly.
Structured and unstructured together.
Exactly. Structured transactional data, customer interactions from social media, internal documents, sensor readings, images, whatever you have. This breadth and depth of data is absolutely crucial for building powerful, context-aware AI applications that deliver meaningful business value rather than models trained in isolation on limited data sets.
And what about managing the AI lifecycle itself?
MLO.
MLOps, or machine learning operations, are greatly streamlined. Through deep integrations with tools like MLflow, the Lakehouse facilitates the entire lifecycle, from tracking experiments and managing code dependencies, to packaging models consistently, deploying them robustly into production, and monitoring their performance over time. You also gain comprehensive compliance and governance not just for the underlying data, but for the models and notebooks themselves, ensuring responsible and auditable AI development. This unified environment also fosters crucial collaboration among data scientists, data engineers, and business analysts on that single platform, eliminating painful handoff friction and promoting shared understanding and innovation. Okay, so big gains for AI. What about the traditional BI side? How does the Lakehouse make life better for analysts and report consumers?
For traditional business intelligence, lakehouses are equally transformative, perhaps in simpler ways. The key benefit is they allow BI tools like Tableau, Power BI, Looker, to directly access the governed, up-to-date source data in the Lakehouse.
No more moving data to a separate BI warehouse.
Exactly. This is a massive improvement because it dramatically reduces data staleness, query latency, and operational costs. There's no longer a need to maintain multiple, potentially out-of-sync copies of data, one in a data lake for raw storage or ETL staging, and another curated copy in a separate data warehouse just for BI. It all resides in one governed place. This ensures your BI users are always working with the freshest, most reliable data available, leading to faster, more accurate business insights, and it simplifies the entire data pipeline significantly. Less moving parts, less to break.
And we touched on ACID transactions earlier as a fundamental shortcoming of traditional data lakes, leading to those data integrity nightmares. How does the Lakehouse definitively address this to ensure the data is actually reliable enough for BI and critical operations?
Yeah, the Lakehouse explicitly includes robust ACID transaction support right on top of the data lake storage. This is absolutely critical for maintaining data integrity and consistency, especially when you have multiple users or automated processes concurrently reading and writing data, which is a very common scenario in modern enterprises.
How does it technically work, usually?
This reliability is typically achieved using formats like Delta Lake or Iceberg, which manage metadata and transaction logs alongside the data files, often Parquet. These formats allow for standard SQL-based operations, insert, update, delete, merge, to be executed transactionally on the data lake storage layer. This makes it familiar and accessible for many data professionals who already know SQL. This direct integration of transactional guarantees into the data lake fundamentally resolves the data integrity issues that plagued those standalone data lakes, turning them into truly trustworthy data foundations suitable for critical business operations and reliable BI. You can finally rely on the data without constant fears of corruption or seeing inconsistent results mid-update.
Okay, so ACID is sorted. Beyond that, what about the flexibility to handle this incredibly diverse range of data types, structured, unstructured, semi-structured, and support a really wide range of analytical workloads all in one platform? How does the Lakehouse manage that inherent complexity without becoming unwieldy?
Lakehouse's fundamentally embrace was often called a multimodal approach to data. They don't discriminate. They seamlessly handle structured data, which is table-oriented, like in a traditional database.
Right.
But they also natively support unstructured data, think images, video files, audio recordings, free-form text documents, as well as semi-structured data formats like JSON, XML, Avro.
Why is that multimodal support so important?
Because the richest, most innovative insights often emerge when you can analyze these disparate data types together. Imagine combining customer transaction data structured with their social media sentiment, text and structured, and maybe transcripts from support calls, audio text. Lakehouses are purpose-built to enable exactly that kind of integrated analysis.
And the different workloads, SQL analytics versus ML training.
They inherently support diverse workloads too. Everything from traditional data science exploration and complex machine learning model training to ad hoc SQL analytics for business users running dashboards and other general enterprise data processing requirements. All these varied workloads can operate efficiently on the same underlying data repository, using the same governance framework. This eliminates the need to constantly move and reshape data for different specialized systems.
What about real-time data?
Yes, that's crucial too. They excel at both batch processing for large historical data sets and real-time streaming data ingestion and analysis. This means you can process massive volumes of historical data collectively, perhaps overnight, but also ingest and analyze high-velocity streaming data from IoT sensors, click streams, live customer interactions as soon as it's received. This ensures your insights are always based on the freshest possible data, allowing for near real-time decision-making and responsiveness.
Okay, we've covered a lot of the what and how. Let's bring it back to the why. What does this architectural shift truly mean for your business? This isn't just about fancy technology. It's about solving real-world business challenges and unlocking new strategic capabilities. What are the key nagging problems that a data lakehouse architecture directly addresses for today's enterprises?
Right, the business impact. The Lakehouse directly addresses several critical pain points that most organizations struggle with daily, sometimes without even realizing the underlying architectural root cause is contributing to the problem. First and foremost, it excels at unifying data teams.
Breaking down the human silos, too.
Exactly. By providing one common architecture and one single source of trusted, governed data, your diverse data professionals, engineers, analysts, scientists, ML engineers can work together much more seamlessly. They're speaking the same data language, operating within a shared collaborative environment. This dramatically reduces friction, miscommunication, and improves overall team productivity.
Which, as we discussed earlier, directly leads into finally breaking down those stubborn technical data silos as well.
Precisely. That's the second major problem solved. It centralizes and governs all data, both structured and unstructured, making it accessible to virtually everyone across your organization who needs it securely, and with the proper permissions enforced by that unified governance layer. This empowers far more users to leverage data for their day-to-day decision-making without needing specialized access to dozens of fragmented, disconnected systems. It really helps democratize data access and foster a more data-driven culture.
What about data freshness? That's a constant battle.
That's the third key problem it solves, preventing data staleness. By continuously updating tables in near real time through its native support for both high-volume batch processing and high-velocity streaming data ingestion, think everything from IoT sensor feeds tracking inventory to real-time customer interactions on your website. Your insights are always based on the freshest possible information. This enables truly agile business responses, not decisions based on data that's hours or days old.
And finally, a huge point of contention and strategic risk for many businesses. significantly reducing vendor lock-in.
Absolutely critical. This is a strategic imperative for many CIOs and CTOs.
Yeah.
The Lakehouse approach, particularly with its emphasis on open formats and open standards at every layer, storage, processing, governance, fundamentally addresses this. Your data is stored independently of any specific tools or vendors you're currently using to process it.
So you can swap things out.
Exactly. This fundamentally future-proofs your architecture because it makes it significantly easier and less risky to swap out processing engines, adopt new BI tools, or even migrate your data to a different cloud provider if your business needs change or a better technology emerges down the line. It frees you from being tied to a single proprietary vendor's ecosystem and roadmap, giving you long-term strategic flexibility and genuine control over your most valuable asset, your data. Your data assets remain yours, accessible and adaptable for decades to come, not held hostage by licensing agreements. Okay, so we've established the why, the compelling business reasons, but this brings us to a crucial practical question. How does a platform like Databricks specifically implement this powerful Lakehouse vision? And what are the foundational technologies within Databricks that make it all possible at an enterprise scale? It's one thing to talk about the concept, but the true value emerges in how it's actually brought to life in the usable platform.
That's a great point. Implementation matters hugely. Let's start with how Databricks ensures that core data reliability and performance, particularly by leveraging Delta Lake Uniform. What does Uniform bring specifically to the Databricks Lakehouse table?
Right, so Databricks builds its Lakehouse foundation firmly on Delta Lake, and Delta Lake Uniform is a key capability within that. Delta Lake itself is that open source storage layer we mentioned, designed to bring robust, enterprise-grade data reliability and performance directly to your data lake files, typically stored in formats like Parquet on cloud object storage.
So it adds structure and reliability to raw files.
Exactly. Think of it as adding a layer of industrial strength, stability, transactional integrity, and speed right on top of your raw, unprocessed data. It delivers the fast query performance that people traditionally associated with data warehouses, but directly on your cost-effective data lake storage. Crucially, it provides those all-important ACID guarantees, atomicity, consistency, isolation, durability, ensuring data integrity and consistency across both batch and streaming workloads simultaneously.
And Uniform. What's its special trick?
Delta Lake Uniform takes it a step further. It allows Delta tables to be read by other query engines as if they were Iceberg or Hootie tables, automatically and without copying the data. This means you get the benefits and ecosystem of Delta Lake, but clients using Iceberg or Hootie readers can still access the data seamlessly. It provides universal format compatibility from a single data copy.
So it enhances the openness and interoperability.
Precisely. It ensures that the data managed by Delta Lake remains accessible to a wider ecosystem of tools and engines, reinforcing that commitment to avoiding lock-in. Overall, Delta Lake, including Uniform, ensures your data continuously flows through your Lakehouse, providing end users with the most complete, reliable, and up-to-date information available without fear of corruption or inconsistency. From a business perspective, companies really value this because it's exceptionally cost-effective. It eliminates the need to manage and pay for multiple versions or copies of the same data just for different formats, drastically reducing storage costs and simplifying the overall data architecture. It transforms that potential data swamp into a highly organized, reliable, and interoperable data asset.
Okay, so Delta Lake with Uniform makes the data lake reliable, performant, cost-effective, and interoperable, turning it into a truly usable foundation. Next up, the governed Lakehouse architecture with Unity Catalog UC. How does Databricks use UC to centralize and streamline governance for not just data, but all the AI assets too?
Governance in a modern Lakehouse architecture, especially one supporting diverse workloads like Databricks does, is absolutely paramount. You need it for compliance, for security, for building trust. Unity Catalog is the cornerstone of Databricks' approach here. Many organizations today are just drowning in data and AI assets scattered across different systems, different clouds, different teams.
Tables, files, models, notebooks.
Exactly. Structured tables, raw unstructured files, notebooks where analysis happens, dashboards visualizing results, complex AI models making predictions, even generative AI assets like vector indexes or feature tables. It's a lot to manage. Unity Catalog provides a single, unified governance layer that centralizes control and visibility over all of this.
Unified is the key word again.
It is. It streamlines governance processes, vastly improves visibility into what data and assets exist and how they're being used, and significantly reduces compliance risks across all these assets, regardless of their type or even where they physically reside, potentially spanning multiple cloud platforms if you're using Databricks multi-cloud capabilities.
And how does that empower teams?
This unified approach empowers data teams to securely discover relevant assets, to tag and classify them consistently, to manage fine-grained access controls, and to collaborate effectively on trusted data and AI assets. Imagine an auditor being able to trace the lineage of a specific data point from its raw source through various transformation notebooks into a training data set, then see which ML model version was trained on it, and finally track where that model's predictions are surfaced in a dashboard, all with clear access logs. That level of end-to-end transparency and control boosts productivity, fosters trust, and unlocks the full potential of the Lakehouse, giving leadership crucial peace of mind about security and compliance.
That sounds incredibly comprehensive. What specific persistent challenges that maybe plagued older systems does Unity Catalog really address, helping to accelerate data and AI initiatives at an organizational level?
UC addresses several deeply ingrained challenges that historically made enterprise data and AI governance such a headache. First, as we just discussed, it provides that unparalleled unified visibility into all data and AI assets through comprehensive lineage tracking and auditing capabilities. You can finally see the whole picture.
No more hidden corners.
Hopefully fewer. Second, it offers a single, fine-grained permission model for access control across all those diverse data and AI assets. This simplifies security management considerably compared to managing separate permissions in databases, file systems, ML platforms, BI tools. It consolidates it all, reducing the risk of misconfiguration and data breaches.
What about finding the right data? Discovery.
That's the third key challenge addressed. UC incorporates AI-powered monitoring and discovery. It can automatically suggest tags, generate documentation, and provide semantic search capabilities, making it significantly easier for users, analysts, scientists, even business users to find, understand, and trust the data they need for new projects or analyses.
And sharing data.
And crucially, fourth, it enables secure, open data sharing through the integrated Delta sharing protocol. This allows you to share live data slices securely with external partners or customers without those costly, risky replication processes. This holistic, centralized approach to governance, powered by UC, not only accelerates data and AI initiatives by making data trustworthy, discoverable, and shareable, but also significantly simplifies regulatory compliance, fosters seamless team collaboration across previously siloed groups, cuts operational costs by eliminating redundant governance efforts in different tools, and ultimately boosts innovation by empowering more users to confidently leverage data and AI assets. It's truly about making data and AI simpler, safer, and more efficient for the entire organization.
That brings us neatly to how Databricks Lakehouse architecture, governed by Unity Catalog, directly benefits those traditional business intelligence and data warehousing workloads. We know the historical issues with old DWs, slow, costly, inflexible. How does the Lakehouse directly combat them and offer superior alternatives specifically for BI and DW use cases?
Right. Those traditional data warehouses, as we've established, inherently suffer from slowness and inefficiency, especially when dealing with today's large, diverse data volumes and complex queries. Their infrastructure often tends to be complex and disjointed, maybe involving separate ETL servers, storage layers, and compute engines, and governance is frequently fragmented across these multiple disparate systems.
And the business impact of those tech issues.
These technical shortcomings lead directly to profound negative business outcomes. Think about it. High costs due to constantly growing data volumes, needing more expensive hardware or licenses, and those keep the lights on, maintenance budgets that stifle funding for new innovative development. There's often a debilitating lack of agility, as engineering and IT staff spend an inordinate amount of time simply navigating system interdependencies, managing complex ETL pipelines, and moving data around just to get it ready for analysis.
Data wrangling takes forever.
Forever. Data often breaks down at scale due to those silos, creating out-of-sync copies, inconsistent definitions, and fragmented development environments, making reliable operations untenable. This leads directly to significant operational risks because critical business decisions might be based on stale, incomplete, or low-quality data without anyone realizing it until it's too late.
And compliance.
And perhaps most critically in many industries, compliance and governance risks are amplified. Limited, Fragmented governance and non-unified audit data across the pipeline expose organizations to substantial regulatory risks, which can incur massive penalties and reputational damage.
Okay, paints a grim picture for legacy systems. So how does the Lakehouse architecture, particularly implemented by Databricks, specifically flip these negatives into powerful positives for the BI and DW world?
The Lakehouse fundamentally resolves these core issues by offering that truly unified platform for all data, analytics, and AI workloads, built organically on top of your existing data lakes, often cloud storage, and sometimes even integrating with legacy warehouses. This means one single, consistent, governed source for all your data, eliminating the chaos and complexity.
What about performance and cost?
It provides AI-optimized price performance. Databricks SQL, for instance, uses sophisticated query optimization, vectorized execution, and built-in intelligence that learns from your specific workloads over time to automatically improve performance and reduce compute costs. This translates to significantly lower overall cost compared to traditional warehouses, driven by both the use of commodity cloud storage and a next-generation query engine, Photon, that dramatically accelerates computing speed.
And governance for BI.
You get that unified, fine-grained governance via Unity Catalog, covering security, end-to-end data lineage, and comprehensive monitoring for all assets, including the tables, views, and dashboards used by BI. This level of consistent control was previously unattainable, especially across the mix of data types often needed for modern BI.
What about sharing BI results or data?
For data sharing, it securely shares not just raw data, but also curated tables, views, and potentially even AI-derived features with external users and organizations, regardless of their platform or cloud, through the open-source Delta sharing protocol, all secured and audited by Unity Catalog.
And connecting to existing data.
And finally, a key capability for organizations with existing investments is query federation. Lakehouse Federation in Databricks allows users to run queries that seamlessly join data in the Lakehouse, with data residing in external systems, other databases, warehouses, etc., without needing to migrate or ingest all that data first. This is done while maintaining robust governance and security via Unity Catalog over the federated queries. This is transformative for companies with legacy systems or complex multi-cloud strategies, avoiding massive data transfer costs and simplifying integration.
That query federation sounds particularly powerful for avoiding those painful Big Bang migrations. It truly avoids the complexities and costs associated with constantly transferring data between lakes and warehouses and dealing with proprietary data formats that prevent direct access and increase vendor lock-in. It seems like a foundational shift in how you approach BI architecture.
It is a complete simplification and unification, not just technically, but operationally. It eliminates the increased cost, the duplicated effort, and the fragmented governance challenges associated with managing multiple copies of data in complex, bespoke security models across disparate infrastructure. You achieve a consolidated, governed view that allows you to manage security, compliance, and cost much more effectively, often from a single pane of glass within the platform.
Okay, let's shift gears slightly. This is where the Lakehouse truly shines for many modern data applications. What are the specific, tangible payoffs for exploratory generative AI, data science, and traditional machine learning when you adopt a unified Lakehouse architecture like the one Databricks provides?
Right, because without a proper Lakehouse foundation, ML and AI productivity faces some significant, often frustrating barriers in most organizations. First, teams often spend an excessive amount of time and resources, sometimes cited as 80% of their effort just wrestling with infrastructure setup, managing dependencies, and DevOps tasks, rather than actually building and experimenting with models. It bogs them down.
Infrastructure headaches.
Exactly. Second, there's the issue of untapped data. A staggering amount of enterprise data, particularly unstructured data documents, images, logs, often over 90%, remains unused simply because it's untagged, unsearchable, and effectively invisible or inaccessible to AI models locked in traditional databases.
Dark data.
Dark data, exactly. Third, performing advanced AI on a mix of structured and unstructured data is incredibly challenging and inefficient without that unified architecture to bring it all together in a governed way. Fourth, there's often a persistent talent bottleneck. A shortage of highly technical data scientists drives the urgent need for more democratized tools and platforms that empower a wider range of users, like analysts or domain experts, to participate in AI development.
And collaboration issues.
And finally, yes, collaboration and handoffs. Teams often end up piecing together various open-source libraries in a fragmented way across different environments. This leads to error-prone handoffs between data engineering, preparing data, and data science, building models. It makes the whole ML lifecycle management incredibly difficult because tracking experiments, managing code versions, ensuring model reproducibility, and managing dependencies becomes complex and inconsistent. These are all critical inhibitors to scaling real AI innovation effectively.
Okay, so the Lakehouse aims to simplify all that complexity and remove those inhibitors. What are the concrete gains then? How does it turn these pain points into accelerators for developing and deploying ML and AI applications?
With a data lakehouse architecture like Databricks, you gain virtually instantaneous, governed access to clean, reliable data for all your downstream analytics and AI applications. No more waiting weeks for data engineers to provision something. You also get immediate access to pre-configured, highly optimized, and often serverless compute clusters, purpose-built for ML and AI workspaces.
Ready to go environments?
Exactly. This means data scientists can focus on the science, not on setting up and managing infrastructure. Critically, the Lakehouse provides the foundational architecture for what Databricks calls data intelligence platforms. This embeds intelligence into every aspect of your data interaction. This includes enabling the rapid development of sophisticated generative AI applications, offering intelligent code assistance within notebooks, enabling intelligent semantic searches of data assets across your entire organization, and truly democratizing data querying through natural language interfaces, perhaps using features like Databricks Genie Spaces.
And it streamlines the entire end-to-end ML workflow, from getting the raw data to actually having a model running in production.
Absolutely. It enables a unified approach that streamlines that entire workflow. From raw data ingestion and preparation, using tools like Delta Live tables, all the way through to model training on potentially massive data sets, sophisticated tuning, robust deployment, monitoring model drift, and sharing insights. Tools like MLflow are deeply integrated into the platform.
How does MLflow help specifically?
MLflow facilitates crucial tasks like preparing large data sets efficiently, training models at scale, using distributed computing, meticulously tracking experiments, parameters, metrics, code versions, artifacts, managing the model lifecycle through a central registry, and deploying models consistently across different environments. This ensures full reproducibility and auditability.
What about flexibility for data science teams?
The architecture also offers incredible flexibility. Data science teams can bring their own preferred libraries and environments if needed, use multiple languages, Python, R, Scala, SQL, interchangeably within the same workflow, or execute their code remotely on pre-configured, customizable, and scalable clusters. You get one-click access to ready-to-use optimized ML environments. This simplifies handoffs among teams, dramatically providing one unified architecture for data ingest, feature engineering in a feature store, model building, tuning, deployment, and continuous monitoring. And it allows you to centralize the tracking of everything: experiments, code, results, artifacts, and manage models collaboratively in one central hub. It makes MLOps a practical reality, not just an aspirational buzzword, accelerating time to value for all your AI initiatives. If we connect this to the bigger picture, the Lakehouse isn't just an endpoint for storing and processing data. It really sets the stage for something even more advanced and transformative, what Databricks is calling data intelligence. This is where AI starts to truly understand your data at a much deeper semantic level, fundamentally changing how you interact with it and what you can achieve.
Interesting. So even with Lakehouses unifying all the data and providing a great foundation, it sounds like you're saying there are still persistent challenges preventing organizations from getting the absolute maximum value out of their data.
Right.
What are these remaining challenges that data intelligence aims to solve, pushing beyond the capabilities of even a standard, well-run lakehouse?
That's an insightful question, and yes, that's right. Even with a unified Lakehouse foundation, we still see bottlenecks in practice. For instance, technical staff data engineers, analysts are often constantly needed to build bespoke dashboards and reports for business users, creating a perpetual backlog and frustration. It's frequently still a struggle for non-technical business users to find the accurate, relevant data they need for their specific questions, often necessitating extensive manual curation, data discovery efforts, and lengthy search processes through catalogs or documentation.
Finding the right data is still hard.
It can be. And now, with the explosion of generative AI, there are amplified concerns around the security, the privacy, and the governance of large language models, LLMs, especially when they need to interact with sensitive enterprise data to provide relevant answers. Fundamentally, these remaining challenges often stem from a lack of deep, inherent understanding of the organization's data, its meaning, its context, its usage patterns within the current data platforms themselves. This is precisely where generative AI emerges as a potent new tool, not just as an application on the data, but as a way to make the data platform itself intelligent.
So data intelligence is really about leveraging AI to understand the semantics, the actual meaning and context of the data stored in the lakehouse. What are its key capabilities that move beyond just managing data files and tables?
Data intelligence, as Databricks envisions it, is truly revolutionary in its scope. It employs advanced AI models, often trained or fine-tuned on your specific organizational context, to deeply understand the semantics of your enterprise data, which is already managed and governed by your Lakehouse Foundation Unity Catalog. This understanding allows for automatic analysis and optimization of data workflows, and it genuinely upgrades existing use cases with entirely new capabilities, making the data platform active and helpful, not just a passive repository.
Okay, what are some of those key capabilities?
Key capabilities include things like natural language interaction. This allows potentially anyone in the organization to simply converse with their data using generative AI, asking questions in plain English, which dramatically democratizes data access beyond SQL experts. It provides semantic cataloging and discovery. Here, Gen AI helps understand your organization's unique data models, business metrics, key performance indicators, your KPIs across different systems. This enables unparalleled data discovery, finding relevant data based on meaning, not just keywords, and can even automatically identify discrepancies or anomalies in how metrics are calculated or used. Imagine your catalog not just listing tables, but understanding what customer lifetime value means across different departments and flagging inconsistencies.
Wow, understanding the meaning behind the data, not just its structure or name. That sounds incredibly powerful. What else does this semantic understanding unlock?
Well, it enables sophisticated automated management and optimization. AI models, understanding usage patterns, can dynamically and proactively optimize data layout, suggest better partitioning strategies, or manage indexing for tables within the lakehouse. This drastically reduces the need for manual tuning and configuration by data engineers, leading to continuous efficiency gains and cost savings. It also brings greatly enhanced governance and privacy. Data intelligence features can automatically detect, classify, and help prevent the misuse of sensitive data, like PII, across your lakehouse, and can even simplify governance tasks like defining access policies using natural language prompts.
And how does it help with building other AI apps?
Finally, it offers first-class support for downstream AI workloads by inherently enhancing any enterprise AI application built on the platform. Because the platform understands the data's semantics, it can better connect AI applications to the most relevant business data, leveraging the learned semantics, those metrics, KPIs, business rules, to deliver incredibly accurate and contextually relevant results. This means AI application developers might not have to spend as much time hacking context and intelligence together through complex prompt engineering. Some of that intelligence is increasingly built into the platform foundation itself.
That's a really comprehensive set of capabilities. So how does the Databricks data intelligence platform specifically bring all this to life? How does it build on its robust Lakehouse foundation using these AI concepts?
Right, the Databricks data intelligence platform is explicitly built directly on top of their robust data lakehouse architecture. It seamlessly leverages that unified governance from Unity Catalog, the open and format agnostic storage layer, Delta Lake, and that single unified query engine, Photon, that spans everything from ETL and SQL analytics to machine learning, AI, and business intelligence. The true core, the engine driving this intelligence, is what they call the data intelligence engine. This engine fuels all parts of the platform by generating and leveraging AI models, particularly drawing on capabilities from Mosaic AI, which is Databricks' suite of tools for building, deploying, and managing AI models, including LLMs. This engine is deeply integrated into virtually every layer and component of the Databricks platform, making it intelligently self-optimizing and context-aware.
Can you give us some concrete examples of how this deep integration of AI actually works across the Databricks platform? How does it transform the user experience or the platform's performance in tangible ways?
Certainly. There are several examples. Take the AI BI Genie, for instance. It's designed to allow the creation of dedicated spaces where both technical and non-technical users think a marketing manager or a sales executive can converse with their own relevant data using their own natural language, their own business jargon. They get insights back that are guided by human-validated responses and curated data, aiming for trustworthy and understandable answers.
So conversational analytics.
Exactly. Then there's platform optimization. The data intelligence engine continuously and automatically analyzes usage patterns and can adjust platform settings like column indexing strategies or data file layout partitioning dynamically. This helps strengthen the Lakehouse foundation automatically for better query performance and significantly lower compute costs, reducing the need for constant manual tuning by expert engineers.
What about governance itself? Does AI help there?
Yes, governance itself is enhanced through Unity Catalog. The platform can use AI to automatically generate richer descriptions and tags for data assets based on their content and usage, dramatically improving the quality of semantic search within the catalog and enhancing the quality of AI assistance across the platform. It makes data discovery far more intuitive and accurate.
And for developers?
An AI assistant is integrated directly into the coding experience within Databricks notebooks and editors. This enhances Python and SQL code generation, provides debugging assistance, and offers powerful text-to-SQL and text-to-Python capabilities, helping developers write complex data pipelines or analyses faster and more accurately.
Performance boosts?
Query performance is boosted too. The engine uses AI-powered predictions about data distribution and query patterns to achieve optimal query planning, leading to extremely fast query performance, often at a lower cost compared to less intelligent optimizers. And finally, for efficient scaling, the platform optimizes ETL jobs and data orchestration by predicting workload resource needs more accurately. This enables more precise autoscaling, ensuring you only pay for the compute resources you truly need precisely when you need them, further reducing waste and cost. It's moving towards an intelligent, self-managing, self-optimizing data system.
So it's genuinely infusing AI capabilities at almost every layer, making the platform itself more intelligent, more automated, and more intuitive to use. You also mentioned building AI agent systems with Mosaic AI earlier. How does this specifically simplify the development and deployment of those more sophisticated enterprise AI applications that can actually reason over your proprietary data? That sounds like the next frontier.
Mosaic AI is really positioned as a key enabler for building and deploying these sophisticated AI agent systems. These systems go beyond simple Q&A. They combine the power of the governed data in the Lakehouse with specialized AI agents, which might include LLMs, other models, or tools, to truly understand your data and solve complex, domain-specific business problems. Mosaic AI provides an incredibly efficient and crucially secure way to connect your enterprise data to these AI agents without requiring data duplication or movement outside the governed environment.
How does it connect the data without moving it?
It can automatically generate essential components needed by AI models, like vector indexes for semantic search or specialized machine learning features, directly from your production data already residing in the Lakehouse, governed by Unity Catalog. This makes it incredibly easy to customize and ground AI models, especially LLMs, with your specific proprietary business context. This is fundamental for building advanced retrieval augmented generation, or RAG, applications, for fine-tuning open-source LLMs on your private data, and even for training both custom LLMs and classical ML models directly on your trusted governed data foundation. It streamlines getting your data into the AI development process securely.
Okay, so it simplifies building these agents, but what about evaluating them? These systems can be complex. How do you ensure their quality, reliability, and safety once they're built?
That's a critical question. And Mosaic AI offers robust built-in evaluation capabilities specifically for these AI agents and RAG systems. You can evaluate and use any combination of models, open-source LLMs, commercial closed-source LLMs, classical ML models within your agent system. Mosaic AI helps you objectively measure the output quality using sophisticated techniques, including AI-assisted judges that can automatically grade responses based on criteria like helpfulness or accuracy. It also provides frameworks for incorporating critical human expert feedback into the loop.
And if you find problems?
Crucially, if quality issues are found during evaluation, the integrated nature of the platform allows you to trace the root cause, maybe back to a specific data source used in retrieval, a flaw in the prompt, or an issue with the model itself. You can then evaluate potential fixes and redeploy quickly, ensuring a continuous improvement cycle for your AI applications. The systematic evaluation takes a lot of the guesswork out of AI quality assurance and helps build trust in the systems.
And just to confirm, all of the sophisticated AI agent development and deployment still operates under that same unified governance framework provided by Unity Catalog.
Absolutely. This is a critical differentiator and extremely important for enterprise adoption. Databricks emphasizes that Mosaic AI provides end-to-end governance specifically for these sophisticated AI agents and the models they use. Customers can govern and apply guardrails consistently across all AI models involved, even if some components like a commercial LLM API are hosted outside of Databricks. Through Unity Catalog and the Mosaic AI Gateway, which manages access to models, it automatically enforces proper access controls based on user identity and data sensitivity, allows setting rate limits to manage costs and resource consumption, helps prevent the generation of harmful or biased content using safety filters, and meticulously tracks lineage throughout the entire AI workflow, from data ingestion and feature engineering through model training and evaluation to final deployment and inference. This unified governance is paramount for achieving responsible, secure, and compliant AI deployment at enterprise scale.
It sounds like these complex AI agent systems, orchestrated through Mosaic AI by combining multiple specialized components, can actually outperform traditional approaches that rely on a single monolithic large language model. Why is that the case? What makes the ensemble approach better?
They absolutely can, and often do, outperform single LLMs for complex enterprise tasks. The reason is precisely because they intelligently combine multiple AI models and components. You might use a powerful LLM for natural language understanding and generation, but combine it with classical machine learning models for structured data prediction, specialized tools for calculations or external API calls, intelligent retrievers optimized for your specific data, vector databases for efficient semantic search, plus those comprehensive evaluation, monitoring, security, and governance capabilities we just discussed.
A team of specialists versus one generalist.
That's a great analogy. This multi-component orchestrated architecture allows for much higher quality, more accurate, more reliable, and more auditable outputs compared to relying on a single general-purpose LLM trying to do everything alone. By orchestrating these interacting components, organizations can deliver AI applications that are more accurate, leveraging the best tool for each subtask, safer, with built-in guardrails and monitoring, and better governed. It's truly a leap forward in building practical, high-value enterprise AI, allowing for highly customized and effective solutions tailored to specific business problems.
Okay, that makes sense. So how does Databricks with Mosaic AI actually guide users through building these potentially complex AI agent systems? What are the practical, actionable steps for a team looking to leverage this approach?
Databricks structures the process into fairly clear, logical steps, leveraging the integrated platform. First, you prepare your data. This uses tools like Lakeflow or Delta Live Tables to reliably ingest and prepare your data, making it ready for AI applications. And the beauty here, as we mentioned, is you often don't need to duplicate or move data out. Instead, essential components like vector indexes or ML features can be automatically generated directly from your trusted production data already in the Lakehouse.
Step 1. Prepare data in place. Step 2.
Step 2 is to build your agents. This involves selecting, customizing, or training the models you need. You might use existing foundation models, open source or commercial via the gateway, fine-tune them on your specific data, train entirely custom models, or simply configure agents to use specific models and tools through Mosaic AI's frameworks. This is where you assemble the core reasoning capabilities.
Step 3. Deployment.
Step 3 is to deploy your agents reliably and scalably into production environments. This typically uses ML Flow for packaging and versioning, and Mosaic AI serving infrastructure, often serverless, to handle inference requests efficiently.
And finally, evaluation.
And finally, step 4 is to evaluate and monitor your agents continuously. This uses both human feedback mechanisms and automated machine-based evaluations via Mosaic AI agent evaluation tools and Lakehouse monitoring to track quality, performance, cost, and ethical behavior over time, ensuring the AI systems remain effective and aligned with business goals. And remember, throughout this entire process, that unified governance layer via Unity Catalog and the Mosaic AI Gateway keeps your data and AI assets secure, compliant, and auditable, ensuring centralized control and visibility from the raw data all the way to the deployed AI agents' responses.
Wow. Okay, this has been a truly whirlwind tour, hasn't it? From the early days of simple data warehouses all the way to the cutting edge of AI agent systems built on data intelligence platforms. But let's bring it back down to earth. What's the bottom line for you, the listener, and your organization? What are the truly transformative, tangible benefits of making this shift towards a lakehouse architecture?
Yeah, let's summarize the payoff. The benefits of adopting a data lakehouse architecture, especially one infused with data intelligence like Databricks offers, are genuinely profound and far-reaching. It's not just hype. It's why this paradigm has rapidly become the new standard across leading enterprises worldwide. It fundamentally changes how organizations manage and, more importantly, leverage their data for real competitive advantage.
Okay, so if you had to sum it all up, maybe give us the top 10 key consolidated reasons why an organization today not only needs but truly thrives with a modern data lakehouse.
Okay, let's try a top 10. First, and perhaps the most immediate and visible benefit, is that it completely eliminates data silos. Your entire data estate, structured, semi-structured, streaming, unstructured, is centralized and unified within a single, cohesive architecture. This unlocks that truly holistic view of your business.
One place for everything.
Second, building on that, it unifies data warehousing, business intelligence, machine learning, and artificial intelligence into one foundational platform. It supports all your workloads, combining the flexibility and cost-effectiveness of data lakes with the reliability and analytical power of data warehouses. It's not just consolidation, it's synergy.
And governance, which we spent so much time on, has to be high on the list, right?
Absolutely critical. The third reason is unified and open governance. This is mission critical for securing and managing all data and AI assets across diverse formats and sources. It centralizes access management, auditing, monitoring, lineage, enabling easy discovery, secure access, and trusted sharing of data across any tool, engine, or cloud you choose. Consistent control.
What about the people using it?
Fourth, it dramatically increases data and AI team efficiency and collaboration. By bringing together the best features of warehouses and lakes and providing common tools and governance, more personas across the business engineers, analysts, scientists can work together much more effectively on the same data. They move faster, simpler, with greater scalability and exceptional cost effectiveness. It accelerates your team's output.
And the tangible cost savings are often a huge driver for many businesses, directly impacting the bottom line.
Indeed. Fifth reason, it substantially reduces overall costs. This isn't just about slightly cheaper storage. It eliminates the costly need to create, move, and manage redundant copies of data across multiple systems. And it significantly cuts down on expensive license fees from multiple disparate point solution vendors. Less complexity, less redundancy equals lower TCO.
What about the engineering side, making life easier for them?
Sixth, it simplifies data engineering. You can much more easily ingest and transform both high-volume batch and real-time streaming data using integrated tools like Delta Live Tables or Spark Structured Streaming, often without the burden of complex manual infrastructure management thanks to serverless options. Plus, that AI-powered data intelligence engine we discussed helps your team understand data quality, lineage, and pipelines more easily, automating some tedious tasks.
And handling modern scale, avoiding redundancy.
Seventh, it scales far beyond legacy solutions, effortlessly handling trillions of records and petabytes or even exabytes of data. This is possible because of that fundamental decoupling of storage and compute, delivering high performance with incredibly low latency, even at massive scale. Eighth, it removes data redundancy. By providing that single unified architecture for all workloads, it eliminates the need for multiple specialized tools and duplicated data processing steps, ingestion, cleaning, ETL, just to serve different use cases. This historically led to those costly, inconsistent, redundant data copies scattered everywhere.
And the commitment to open source, which we discussed as a core principle, remains a foundational benefit, doesn't it?
That's our ninth key reason. Modern lakehouses heavily leverage open source at every layer. Think Delta Lake Uniform for unified multi-cloud storage and data reliability built on OpenParquet, Apache Spark for powerful processing, MLflow for managing the ML lifecycle, Delta Sharing for securely sharing live data using an open protocol. This deep commitment to open approaches provides unparalleled transparency, fosters community innovation, and fundamentally prevents vendor lock-in, giving you long-term control and flexibility over your data assets.
Okay, number 10, the future.
And finally, the 10th, and perhaps the most forward-looking and strategic reason. It serves as the foundational platform for data intelligence. This enables that deeper semantic understanding of your Lakehouse data we explored. This powers intelligent searches, context-aware code assistance, automated performance tuning and scaling, enhanced visualizations with tools like Databricks AI via Genie, and truly democratizing data access for non-technical users to query their own data using natural language. It turns your data from a static, passive asset into an active, intelligent participant in your day-to-day decision-making processes.
So there you have it, a truly deep dive into the data lakehouse, particularly viewed through the transformative lens of Databricks' integrated platform and its vision for data intelligence. We've gone from understanding the persistent limitations of past data architectures to seeing how a unified, intelligent platform can potentially unlock unprecedented insights and radically accelerate your AI initiatives.
Yeah, and this concept of a data intelligence platform built directly on the Lakehouse Foundation really highlights a crucial point. The future of data isn't just about storing it anymore or even just processing it efficiently. It's about truly understanding it its meaning, its context, its quality increasingly with the help of AI, making it an active, intelligent participant in every single business decision.
Exactly. And I think it leaves us, and hopefully you, the listener, with a truly compelling thought to consider. In this era where data is exploding in volume, velocity, and variety, and AI is disrupting virtually every industry, how will you and your organization leverage a unified data strategy built on a lakehouse and enhanced by data intelligence to not just keep pace with the change, but to genuinely innovate, differentiate, and ultimately future-proof your operations? It seems the lakehouse isn't just an architectural choice anymore, it's rapidly becoming a strategic imperative.
Well said. We certainly hope this deep dive has given you a clearer roadmap, sparked some new ideas, and provided some valuable insights for your own data journey.
Thanks so much for joining us on the deep dive. We look forward to our next exploration.